Alright, welcome. More on. The first question here, they say a guitar string is 75 centimeter long. The wavelength of its fundamental note is, they ask you to solve for wavelength. First, the guitar string is 75 centimeter long. And because they give you centimeter here, you need to know what will be the relationship between wavelength and centimeter, or length, wavelength and length. What will be the relationship? The relationship is, to solve this question, you say solution wavelength equals 2L, where this 2L equals 1 wavelength. You see, and now from our question, they give us our L to be 75 centimeter. You see, from here, the wavelength of the fundamental note is, so all you just need to do now is to plug in your data into this formula and you get your wavelength. You say wavelength will be 2 times 75, 150 centimeter. You don't need to go far. So your number one, the answer now 150 centimeter. We'll go to the next one, number 2. Now let me give a task before we go to number 2. The task with this question is, a guitar string is 200 centimeter long. The wavelength of its fundamental note is dash. So that's the second one you saw for me. Let's go to the next question, which is our number 3. For this series, now only calculations we will solve. We don't already do series, so we say we dey touch non-calculation. So the question, see the question here, number 3. A herdsman yelling out to fellow herdsman had his voice off reflected. A herdsman yelling out to fellow herdsman had his voice off reflected by a cliff 4 seconds later. What is the velocity of sound in air if the cliff is 680 meters away? They ask you to solve for the velocity. Now you need to know something called the echo formula. The echo formula now be this: V equals 2x over t. So if you come back to our question, number 3 question, they give us the x is they give us time 4 seconds. So we go, when I want to solve now this t, I go write them as 4 seconds. This 680 meters, so they give me here, I go put them here as x, 9 be x. Now I can solve for v. So it's very easy. Plug in your data. You could just say 2 times 680 over, waiting be t. T na 4 seconds over 4. So your final answer will be v equals 2 times 680 divided by 4. Punch your calculator. 2 times 680. 2 times 680. Sorry, I try punch. I make mistake. 680. It will give you 1360. If you divide this one by 4, divide by 4, the final answer will be 340. 340 meters per second. So your answer is 340 meters per second, which is option C. We'll go to the next one where you get solving. Remember now, this one are only the questions where you get solving, but I will leave you with a task. What will be the task I will leave you with now? Solve this question for me. Listen though, I know we'll type the question down. A herdsman yelling to a fellow herdsman heard his voice reflected off a cliff 8 seconds later. What is the velocity of sound in air if the cliff is 320 meters away? That's the question you solve for me. Next one is number 4. This number 4 here we carry diagram. So we'll say number 4. I'll read the question. It's in a resonance tube experiment, which is illustrated in the figure, velocity of sound in air is 327.68 meters per second. The frequency of the tuning fork used in therefore is, first we'll write our formula down. So we'll go and notice then give us length here, but it no show because of the clear the typing, but they give us velocity. This one here now be our velocity. They ask us to solve for frequency. frequency. So you go say so you need to note this: lambda equals 4L in a resonance tube. So if they give equation where they say in a resonance tube, lambda is always equals to 4L. Now, if you check the diagram, this place no clear, this place now 16. So I go write anywhere where I see L, 9 be L now 16. So I go come down, I go say lambda equals 4 times 16. And 4 times 16 will give you 64, right? 64 meters, which is actually our lambda. But you're asked to solve for the frequency and they give you a velocity. So the next one, this is the first step. The next one you go use V equals F lambda. The same way you solve for frequency. So you go make frequency the subject of formula. Now here most students they get it wrong. They feel say they very hard to make frequency subject of formula. I know they hard. If they say make and subject of formula, they mean say make it stand alone. And how do you make this stand alone? Watch what I want to do. I go write this one. I go write F like this. Then I'll come write this equal to. I'll come write this V. This lambda way there with the F, I'll come write them under over lambda. You know how you see I write F here. I can't say equal to. I can't put this V. Now I just carry come here. Then this lambda will be there with the F. You write them under. You know hard. I don't want to solve complex process. I just show you so. So next, if you plug in our data from our equation, the velocity is 327.68. So you go say 327.68 over 64. If you punch your calculator, I punch my own here. We know the fake one for this side. They get frequency equals 5.12 hertz. The unit of frequency now Hz, they call it hertz or hertz. Next, I'll give you the tax. So take this tax down I won't give you. In a resonance tube experiment, just like the one illustrated in the diagram above, the length is given as 32 centimeters and a velocity of 680 meters per second is given. Calculate the frequency of the turning fork. Now here I go end this video. The next video will continue. This will make the video not too long. If you say you get question after going through this video, if you drop them for the comment section, or if you snap, send to us on our WhatsApp group for more explanation. If this is not your first time coming across our clip, we dey run classes to prepare students for A-level and also entrance examinations across Nigeria. If you want to be part of the class, I will leave link where you go fit take chat me up in the description box of this video. Thanks for watching. I'll see you in the next one.